Today's word is everyday chemistry. Let's go. Science is all around us. Our bread toasting, our tongues tasting. Chemicals reactions happens every day. Substances become something new not just by cutting or freezing or physical change, but by changing what they are, their chemical composition. When we go for a drive and turn the key, sparking the engine, fuel and oxygen became energy and exhaust. We're chemistry in motion. At the park, plants are growing and making food from sunshine, water, and carbon dioxide. That's chemistry too. Whether we're raising, cloud watching with slow deep breaths, or spring painting, our respiration is chemistry. At the playground, the slide is lasting. Chemicals reactions transform. Our tummy is digesting a half-eaten apple turning brown. That's picnic chemistry. At best time, shampoos forms lifting away sweat and dirt. Tiny chemicals reactions get our hair clean. Our dough rising, the stove lighting. Chemicals reactions happens in the kitchen too. Dishwashing records sudsing, washing away oil. It's clean up chemistry. The flashlight shining, battery power. You hold chemicals reactions in your hand. You and me loving that chemistry too. Everyday chemistry. Chemical reactions are all around. We think of chemistry as science that happens in a laboratory, but chemical reactions happen every day, not just in labs, but in our lives. Lives. Chemical reactions involved the transformation of substances by changing their composition, what they are in terms of atoms and molecules, and the bond between them. Ask these 3 questions to help determine if a chemical reaction has occurred. Did the change create something new? Can it be easily undone or reversed? Are there new physical properties? Look for changes in color or smell, or the production of heat, light, sound, or gas. Bread. Chemicals and physical changes. Chemical reactions happen in many places, but some of the most fun and easiest to observe, not to mention most delicious, happen in the kitchen. Consider baking bread. When you mix flour, water, yeast, and salt in dough, it starts as a small blob in the bowl. After a few hours at room temperatures, what do you see? The dough is much bigger. It is filled with air bubbles. It smells different from the ingredient you start with. A chemical reaction has occurred. The yeast has fed on the sugar that make up flour and produce carbon dioxide and another substance called ethanol. Then, when you put the dough in a nice hot oven, how does it change? With time, it grew even bigger, becomes darker in color, and taller in textures. It holds its shape. When you thump the loaf, it sounds hollow. Not wild physical changes have occurred. The water in the wet dough has evaporated, but also a chemical reaction has taken place. The sugars in the flour have caramelized. Now when you cut a slice of bread, it looks different from the whole loaf, but that's a physical change. The bread that makes up the loaf is the same as the bread that makes up the slice. If you toast that slice and it gets brown and crunchy, it may be a little burnt. That's a chemical change. The toasted bread is a different substance than the untoasted bread. Science is delicious. Thank you for the watching. Bye bye.